Hello, today we are talking about temperature and how different locations on Earth have different temperatures. I have a couple of slides so that you can follow along and have some images. So here we go. All right, so these are your 5 goals. So we're going to, take a second, pause, write these down so that you know what we're supposed to accomplish by the end of the lesson. All right. So first of all, heat is the energy that is transferred from one object to another because of the difference in their temperatures. Temperature is a measure of the average kinetic energy of the individual atoms or molecules in the substance. So remember that molecules in any substance are moving around. The more they move, the more kinetic energy they have and the hotter they are. Temperature or heat always flows from high temperature to low temperature. A thermometer is the instrument that we use to measure temperature. So just some general knowledge about temperature that you should all know. Water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. It boils at 100 degrees Celsius or 212 degrees Fahrenheit. There are 3 mechanisms of heat transfer. The first one is conduction. This is the transfer of heat through matter by molecular activity. So as you can see here, the heat is being conducted from the fire to the metal pot to the handle. So these surfaces, the 2 surfaces must be in contact because energy is transferred between colliding molecules, and if the molecules aren't touching, then they can't collide. There are different substances that are better conductors of heat than others. In our situation, we're talking about weather and climate. Air is a really poor conductor of heat. And so that means that conduction really only occurs between the surface of Earth and the air directly above it, so not very much air at all. The second mechanism of heat transfer is convection. This is a transfer of heat by mass movement or circulation within a fluid. Fluids can be things like air, water, or the mantle of the Earth. This is responsible for most heat transfer in our atmosphere. The third type of heat transfer is radiation. This is the transfer of heat through electromagnetic waves that travels in all directions from its source. This one needs absolutely no medium to travel through. It can be transferred through the vacuum of space. So as we see down here in our little picture, we have our heat source, our fire, and that heat is radiating out in all different directions. This is how we get heat from the sun. And this is also how the energy that is re-emitted from Earth's surface gets sent out. All objects that are not at absolute zero radiate heat energy. Hotter objects emit shorter wavelengths, so the wavelengths of electromagnetic energy coming from the sun are much shorter, and then cooler objects emit much longer wavelengths. So like when the Earth is emitting infrared radiation, those wavelengths are longer. Variation in temperature is due to many things, including latitude, geographic position, differences in the heating between land and water, altitude, ocean currents, and cloud cover. So the first one we're going to talk about is latitude. So this is the distance north or south of the equator. So the equator is right here, distance north or distance south. They're the ladder rungs within the latitude-longitude system. So at the equator, the Earth is receiving more direct sunlight all year round. So this is the most intense radiation heat transfer right here, and so that leads to warmer temperatures. At the poles, the sunlight is more indirect, and so since that radiation energy is spread out over a larger area, that results in lower temperatures. And then we have land versus water. Land heats a lot more rapidly and releases heat more rapidly. So that means that over land, temperature variations are going to be much greater. So you might end up with hotter days and cooler nights. And then over water, it heats more slowly and releases heat more slowly. So the temperature variation over water is going to be a lot less drastic. Your daily high and daily low are going to be a lot closer together. And then we have geographic position. So this is where a location is in relationship to other features such as large water bodies, sides of a continent, and mountain ranges, and then also the prevailing winds and prevailing ocean currents that are affecting an area. And then we have altitude, which is the height above sea level. As we know, temperatures decrease as altitude increases in the troposphere. So as you go up a mountain, you're going up in the troposphere. So that means that higher altitudes are going to have cooler temperatures. Lower altitudes are going to have warmer temperatures. Then we have cloud cover. Clouds have pretty high albedo because they're white and they're made of little shiny ice crystals. So they reflect a lot of incoming radiation back into space. So if you have more cloud cover, it's going to reflect more of that incoming solar radiation back into space. So you're going to have cooler temperatures in the day. At night, clouds can also help to trap some of that infrared radiation that Earth is re-emitting and trap it closer to Earth's surface, so it'll keep the surface a little bit warmer. All right, and then last but not least, we have isotherm. Iso means same, therm means temperatures or heat. So these are lines on a map that connect areas that have the same temperature. So as you can see, areas that are between 70 and 80 degrees are marked in orange. Here, temperatures that are between 60 and 70 degrees. So this is our 60-degree line here. This is our 70-degree isotherm here. And so these areas are in between. All right, and we'll practice drawing these a little bit more. We will do a lab or two to help you visualize some of these different changes, and we will do more work with drawing isotherms on maps a little bit later.